Hello, good afternoon. My name is Axel Nothoft. I'm the course director for the MSc Applied Biomedical Science course. Welcome to this presentation about our course. Just want to make you aware there ought to be a chat window on the right side of your screen. Go ahead and post us any questions. I will give a presentation in a minute, but you can start typing in questions while I speak. Some of my colleagues, if there are any in the background, helping out, might start providing some answers while I'm speaking already. So I'm going to switch over to my slides. Where did we go? Over here. Okay. Just doing a little bit of a setup here. Okay. So the MSc Applied Biomedical Science course was recently renamed. In case people have looked at our courses in the past, it used to be called MSc Translational Medicine, but the course contents haven't really changed at all. And in fact, Applied Biomedical Science is really a synonym for translational medicine. So I wanted to briefly start by explaining the key concept of translational medicine that underlines the design of this course. If you hear sort of some strange noise in the background, that's a thunderstorm happening outside my window. So I'll talk about this concept of translational medicine, explain to you the course rationale and the kinds of jobs that the course might prepare you for, take you through the course structure, and I will mention what kinds of assessments we use in order to provide marks on your performance of the various modules. So what is translational medicine? As I said, the course used to be called MSc Translational Medicine, and the contents haven't really changed, but that's the key buzzword that really the entire course is based on. So it's often transcribed with this phrase, from bench to bedside to community. So when we talk about translational research, translational medicine or science, what we mean is the kinds of research and activities where people use breakthroughs or new understanding in the very basic sciences and try to translate into advancements in medicine or population health, by developing new medicines, new practices, new drugs, and so forth. New diagnostics as well. So just to give you an example, for example, so a famous example of translational breakthrough would have been in the 1990s when researchers were analyzing the HIV virus, which causes AIDS. At the time, many people were still dying from AIDS. And what happened is that basic researchers discovered that the HIV virus is reliant on a protease that cleaves, that produces some of the key proteins that the virus needs in order to be effective. And the discovery of the protease led to its purification and the determination of its crystal structure. And then based on this crystal structure, translational researchers and companies were then able to design drugs in order to inhibit this enzyme. And as you can see on this graph here, this then led the introduction of a combination therapy of these HIV protease inhibitors with other drugs inhibiting other enzymes in the virus, led to a dramatic decrease in the number of people dying from AIDS. Another example would be the HPV vaccine. HPV is human papillomavirus that's responsible for cervical cancer. Again, it would have been basic research and basic scientists that isolated the virus, understood its role in cancer, and then that eventually could be translated into the development of a vaccine, which, as you can see on this graph, led to a quite dramatic decrease in the number of people being infected with this virus. And that will reduce dramatically the number of people getting cervical cancer. So I just wanted to explain to you why we developed this course and how we designed the modules that make up our course. It was based in large part sort of on information that we got from the sector. For example, the Association of the British Pharmaceutical Industry. Yeah, so we looked at their input. Members of this organization were part of our validation team that helped design and approve the course. So they realized already a number of years ago that there were major skills shortages, specifically in this area of translational medicine, clinical pharmacology, and biomedical science. Yeah, so the course was really designed to prepare students, on the one hand, to work in industry, like the pharmaceutical or biotech industry, or to prepare you also for a career in maybe academic research by doing a PhD first. So many students that have done the course in the past were, either went on to do PhDs, they went into medicine, or they might have gone on to jobs also in the pharmaceutical or biotech industry. So we have quite a few different examples of that. We try to cover subjects that are in really high demand based on other criteria. So here you see a salary survey. So where this magazine New Scientist did a survey to see sort of what companies found most difficult to hire for. And you can see, so right at the top of this list are biological sciences, data analysis, bioinformatics, statistics as well. So all subjects that programming down here, life sciences, data management, all subjects that we then went on to cover in our course. There was also a report generated for the government a couple of years ago, and pointing out that there was a great demand for people with skills, particularly, and understanding in this area of biomedical science / translational medicine. Here again, just to reinforce the idea that there are jobs out there and that they are quite well paid. In this table, you're looking on the left and at average salaries. This table is a few years old. This would have gone up quite a bit by now. But you can see, again, sort of statistics here, clinical trials, clinical data management, and again, bioinformatics is really one of the key skills. It is very much sought after in all areas of biomedical science and translational research these days, life science. Yeah, so these jobs are in demand and they are well paid. So let's then start looking at the course in a bit more detail. Like every sort of one-year postgraduate science course, the MSc Applied Biomedical Science consists of 180 credits. And you can see we have 8 modules spread over 3 semesters. In semester 1, we have case studies in drug discovery and development. This module looks in the first part at the development of, as an example, of malaria treatments. And then in the second part, you will see a lot of presentations of translational researchers here at St. George's that will talk about their actual science. So you get a direct insight into what's happening at the coalface in this area of research here at St. George's. The second module listed here for semester 1 is Genomic Technologies and Clinical Diagnostics. This module is often shared every other year with clinical geneticists and goes into some detail specifically in the area of genomics, specifically clinical genomics. Yeah, and the background to this is that obviously genomics is an overriding, very central area of great importance these days in pretty much all areas of biomedicine. Then we have a module called Research Methods and Management. This consists, on the one hand, of a number of lectures covering various sort of generic aspects of research management. And on the other side, we also actually provide quite a bit of training on scientific writing, which is of course a very important skill if you want to do well as a scientist when you want to apply for funding and document your research. Then probably our most popular module is clinical trials, which is all about clinical trials management and is run by colleagues here at St. George's, very heavily involved in frontline clinical trials management, both in the UK and abroad. In semester 2, we have a 30-credit module called Big Data and Biomedicine. In this module, you will learn how to analyze mainly genomics data, functional genomics data, such as RNA-seq, RNA, microarray data, ChIP-seq data, for example, but also microbial genomics and human genomics data as well. As an important part of this, you will learn skills, especially programming skills. We focus specifically on the R programming language, which is used quite widely in this area, and Excel as well in some of the lectures and some of the sessions on human genomics and other tools that are commonly used in this field. Yeah, so this is really, I think, one of the major things that makes our course different, I think, from any other courses is that that you would get a very good, that you would acquire very good R programming skills and data analysis skills. R programming also is sort of a key aspect of the population health research, right? So the subject, the area of research here is, of course, very different, but the tool, again, used in many of the workshops is going to be the R programming language. And then we have a module on personalized medicine, obviously sort of one of the central areas of interest in modern medicine. And then from sort of April onwards until July or so in semester 3, you would do a research project by joining one of the research groups at St. George's. In terms of assessment, we have now basically converted almost all of the assessments on our course to take-home open book assessments, with the exception of the Genomic Technologies and Clinical Diagnostics module, which is an exam where you have to analyze data provided in an Excel file and have sort of more of a limited time to provide your answers and do your analysis. But all the other assessments are essentially take-home assignments. In the case of case studies, research methods, and clinical trials, these are papers. Clinical trials is a mini trial protocol. In big data and population health, the assignment are data analysis projects. And in personalized medicine, this will also be sort of a news and views type article that you would have to write. The research project is assessed through 3 different components. One will be a dissertation that you have to submit. The second is a research presentation, and 15% come from a grade that you get from your project supervisor. Just to give you an idea, so how much time is involved in studying on this course. So formally, a 15-credit module is typically equated with 150 hours of study, of which only a small fraction though are actual contact hours, involving workshops and seminars. And obviously, there's always going to be a lot of self-study involved on a course like that. For the research project in semester 3, we would be expecting you to spend sort of 35 to 4 hours per week on your research project, working in the lab or working on your data analysis project. And then there will be about 1 month of that time should be dedicated to dissertation writing. Yeah, so while in semesters 1 and 2, there's quite a bit of extra time, as I'll show in a moment, where you don't have to come to university. In semester 3, we would ask you to sort of dedicate that chunk of time entirely to your research project. To give you an idea of what the week would look like, in this case here in the autumn, in semester 1, we've designed the timetable such that you would have to come into university only 2 times a day. Then there will be a lot of workshops and teaching happening face-to-face, usually in most cases on those days. So it will be a bit packed, but that way you only have to come into university 2 times a week. Yeah, but in addition, of course, to that, during the days where you do not have to come to university, you would still have to do quite a bit of work at home. Obviously, you can come to the university and use the library and our, study facilities here as well if you prefer. Yeah, here's another example just to illustrate that there's an online component sometimes as well, as you can see here at the top in green, clinical trials online ethics course. We also, sit on the next slide, the clinical genomic technologies module is delivered partly through the format of a MOOC, so of an online course that's supplemented with weekly or bi-weekly webinars as well. So a lot of that teaching for this specific module right here, the genomic technologies module, will be happening online, but most of the other teaching will be face-to-face. Okay, yeah, so as I mentioned earlier, just to sort of mention assessments again, except for genomic technologies, pretty much all the other assignments are open book take-home assignments. And so you're welcome to contact me by email at any of these email addresses, or call me, in fact, on my phone. I will also be happy to invite you to sort of speak to me one-on-one if somebody's interested, to come and have a more in-depth discussion of the course. And with that, I'll switch back to the screen over here, stop sharing my PowerPoint presentation, and I'll be happy to answer any questions that people might have. Okay, Samuel, hi. What do most students do before this? It's been really a great variety of students coming in with different degrees. A lot of students come in with biomedical science degrees. We also had students with pharmacy and pharmacology degrees. We had a medical doctor once on the course. We had a student with a chemistry degree. Sort of typically we're looking for students who have already some background in the biological sciences, or any aspect of the biological sciences. The chemistry student convinced me, though, that he was really interested and that he would study hard on the course, and in fact he ended up at the top of his class at the end of the year. So yeah, great variety, but I think students with a degree in biology, biochemistry, especially biomedicine, would probably get most out of this course. But something, again, call me up, something to discuss. Also, to give you an idea maybe of sort of what students went on to do after they finished the course, if you go to our website for the course, there will be links to some, which I'm putting the URL here in the chat. You find detailed information on all the different modules, exactly what do we teach on the modules, but there will also be some statements and some pages with information from students who've previously studied on our course. Again, I'm going to put my contact details in here. people want to speak to me directly at one-on-one in person, email. And my phone number too. Okay, Cherry, thank you. About possible research projects. So we had a great variety. So let me think of something. We had students who did sort of genomics projects, analyzing, for example, doing PCR of patient samples to look for mutations in genes that were likely involved in causing certain diseases. That was one student. We had a student working on the COVID protease enzyme as well. We have a colleague who studies that. We had students who worked on learned how to use the CRISPR-Cas technology in order to knock out genes in cultured cells, in order to study their role in pancreatic cancer. We had a student working who then went on actually to do a PhD with the same supervisor, working on rat brains, and trying to remember exactly what that project was about, but he was sort of interested in pharmacology and the function of certain receptors in the nervous system. I myself will offer a project on the regulation of cholesterol. You're sort of looking at the transcriptional regulation of cholesterol metabolic genes in cultured cells. What else? Sort of that will hopefully give people just a few ideas. And Jerry, asking about opportunities for new cohorts. So the very similar projects will be available in the future as well. I haven't received the latest list of projects yet that will be offered officially for next year, but I often have conversations. I have conversations essentially with all new students coming in about their research interests, and we have an in-depth discussion if they're interested in a specific area that's not on our list yet. I often sort of approach colleagues on behalf that I know work in the area of the student's interest, and arrange for projects that meet more closely their interests. How many students? In the past, Samuel, we had typically about 7 students on the course. So 7 to 10 students. So it's generally a rather small course. So very much of a family kind of atmosphere on this course. St. George's is a very small university. Typically, you get to know pretty much everybody. One of the things I think that make us a little bit different to other bigger universities is that you have very easy access to your teachers. Pretty much everybody has an open door policy. You can knock on people's doors. People are very, very accessible. And that is the feedback that we have received consistently from students, that was something that they really appreciated. Obviously, at this stage, we don't know yet how many students are going to be on the course next year, but I expect that it will be similar. Cherry is asking why somebody might choose our program over a more traditional biomedical science program. I think one of the key things that makes us different is that we offer programming skills as well. Students need to have a look at the modules that are offered in the different courses that are available around London, if this is where you'd like to come and study, and see whether the programs have modules that cover your interests, and whether those modules are likely to sort of provide you with the skills that will give you an edge while looking for a job later on. And I think we cover those really well. And that has been the experience of students who've left the course. They all did quite well. We had a couple of students who really used this course as a stepping stone to apply for medicine afterwards, and they have been successful too. But especially those programming and data analysis skills have been a major factor in helping people getting jobs afterwards. In fact, one of our former students now works just a few doors down the hall from me as a data analyst. In fact, he trained on our translation medicine program, then got a job as a data analyst with our pediatrics department here at St. George's. Other people have gone into biotech jobs. We had another student who got a job with a biotech company, started out doing wet lab research, but then very quickly became the company's local expert on bioinformatics, applying the bioinformatics skills that she had learned on our course. In both cases, these students had no programming or sort of computer-based data analysis skills at all before they came on our course. So we don't expect that people come in with prior knowledge or skills. But I think we do a pretty good job in providing very relevant training in these areas. Yeah, so I think what distinguishes courses like our biomed program and other obviously other MSc biomed programs for more specialized areas is that we cover sort of a broad range of subjects and skills, and so that I think is something that everybody must sort of decide on their own from their own personal perspective, is whether they'd like to sort of get a broader education, some broader exposure, obviously with the opportunity to specialize quite a bit during the research project, or whether you want to go into a very much more specialized area of study at this stage. But thanks a lot for that question, Cherry. I think that's an excellent question. Hi, Samuel. Yeah, excellent question. Obviously, we have two courses in biomedical science, the MRes Biomed and the MSc Applied Biomedical Science. So the biggest difference between the two courses is that the MRes has a much larger research component, right? So our MSc has a 60 credit research project, and the MRes has a 105 credit research project. So, I mean, if you're really, the MRes is obviously maybe a better option if you're really keen on spending most of your time in the lab or working in your research project. The drawback for a lot of people with that is that it's then difficult to sort of combine study with working on the side, because during your research project, you would be expected to essentially spend 100% of your working hours on your project, which is mostly in a research lab or doing data analysis if you're working on a bioinformatics type project. Yeah, with the MSc, which are generally more popular, just judged by the number of students, you cover more taught aspects, so there's always a greater number of taught modules, and a smaller research project. Yeah, but I mean, experience has shown that even our 60 credit research project is enough to prepare you for a PhD, for example, or for sort of very practical work in the biotech sector. Thanks for that question. So, I mean, up to this point, there wasn't really a lot of overlap in the taught. Obviously, the MRes has some taught modules as well. And it's possible that, some of our modules will be offered as electives on the MRes, on our own MRes program next year as well. Again, if you're undecided between those two courses, I think it's important to sort of make appointments with myself and maybe one of the course directors for the MRes and discuss exactly the advantages and disadvantages. Cherry is asking if we had any intercalating medical students. Yeah, we had one also in the past. And that is, I think, we're a very good program for students who are interested in doing an intercalated master's. Yeah, he did extremely well. I think he finished also at the top of his class that year, and really enjoyed it. It's obviously what we do is obviously quite relevant for medics who would like to sort of get involved in research as well. And the program is exactly the same. We at the moment we don't have any electives, so it's sort of what I showed you earlier in terms of modules would be the same for any students that joins the course. The other opportunity, just to make students aware, is that you can also, for your research project, you can go abroad. There's funding available to join a research lab, for example, in Spain or Germany or the Netherlands. Students have also gone to Denmark. And for that intercalating medical student, for example, did this project in Barcelona in Spain. Had an excellent experience. Again, if you'd like to meet me and sort of discuss any aspects of the course in more detail, Samuel or anyone else who might be interested in studying here, don't be shy. You're more than welcome to give me a call. We can meet on Teams or here in person and discuss this in more detail. It's obviously an important decision what course to join.